Hello everyone. We will be studying linked list today. What is it? It is a non-contiguous linear data structure where individual elements, nodes, are allocated one by one sequentially. Big definition. First, let us understand what is a contiguous linear data structure. For example, this array, if you clearly see, the memory address of the first index is 9568, then 9572. And if you see properly, you can observe a pattern that they are equally spaced. Each memory address is just 4 bytes after the previous memory address. However, in case of linked list, this does not hold true. I mean, here the memory address of each individual node is not uniformly spaced with respect to the previous one. Here you can see the memory addresses are just randomly taken. Now, if I have to understand what actually is a linked list, you can visualize it as a train with one engine and multiple bogies. Here in linked list terminology, we will call the engine as the head node and the remaining bogies as normal nodes. Fine. Let us see the advantages and disadvantages of linked list. Let me bring out the laser pointer. Okay, advantages of linked list: easy insertion and deletion. Here we have the advantage of inserting and deleting elements from both sides or even from between. Other than that, no fixed size. So one constraint of an array, wait a minute. So the biggest constraint of an array is it has a fixed size. So what if after inserting 6 elements, I think I have to add one more? I cannot because the size is fixed. But in linked list, we do not have that problem. We can append as many nodes as we want unless it exceeds the system memory. Efficient allocation of memory. Here the memory allocation is very efficient. What are the disadvantages? Slow searching. Here, since the nodes are not contiguously arranged, we cannot apply binary search on them. Other than that, 0 1 accessing of elements not possible. What is that? Suppose in this array I want to access 98. I can clearly write ARR of 2 because it is the second index, 0 index, in a 0 index notation. However, if I want to access 12, I cannot directly access 12. For accessing this 12, I have to go from here, from this 12, then to 56, then can I only go to this 12. Fine. Memory needed per element node is good. Okay. So here if you see, here we have a value for every node as well as the address of the next node. So here the memory per node is higher. Now, how do we implement this? Uh, we will be looking at the C++ implementation. So just a few prerequisites. One needs to know what are pointers and what is a structure, and also basics of object-oriented programming like class, function. These things. So what will be in the structure? Let me zoom it. Fine. So there will be a value that will store the value of a particular node. Here, for the examples that I will be showing later, I have taken an integer value. And next, what is next? Next will be a pointer of node star data type, which will point to the next node. Okay. So what is it? See here, as you can see, here 12 is the value of this node and B3 is the address of the next node. So in each node, I have to store two things, the value of that node and the address of the next node. So let us take a look at the implementation part. So now let us look at the implementation of the structure. I will Now I will define the class. the global variable, which will be the head node. Now, I will also be defining a constructor. It is not compulsory, but it's a good programming practice to do so. That's it. So now the main method where we will do all our work. Just to see it is working or not, I'll check for any compilation errors. Let's check. Yeah, it's working. Fine. So let us take a look at few operations that we can do in a linked list. First is insertion at start. So suppose this is my new node. I want to append it to the beginning. Suppose this has a value v. But basically from the diagram we can clearly see that upon creating the new node, I will initialize this address. I will fix this pointer with the address of the head node and change the value of head from this to the new node. Clear? It will be clearer when I show the implementation. Fine. Insert at end. So what I will be doing here is the same thing just at the end. So the changes that we have to do here are I will reinitialize the last index which was previously null with the address of the new node and the next pointer of the new node that I will be adding will become null. That's it. Let us take a look at the implementation. It will be clear to us. Fine. Let us move ahead with the implementation. So here what did I do? I created a new node with the name new node. I assigned its value with data that is being passed as a parameter. I changed the next pointer to head and I reinitialized head with new node. Now if you look at this, you can clearly see what I first did. I created this, wait a minute. I created this new node. I created this new node, then set its value as data and pointed the next pointer to head, and now reinitialized head to the new node that I just created. Fine. So same thing. I create the new node. I create the new node, then fix its value with data and the next pointer with null. Now here also I create a temporary node. My bad. This will point to head. Why? I'm creating a temporary node temp which will point to head and then keep on going to the right until its next pointer points to null. So it will move from this to this. See its next pointer is not null. Then move to this. See its next pointer is null. Stop here. Stop here. Then temp dot next will become new node, which is what I actually want. So that is the insertion operations that take place in a linked list. Now let us look at a few more operations, deletion operations. So delete from start. What this does is this is the head node. What I will do is I will reinitialize head with head.next. Why? Because I want to what I want to do is basically delete it from the beginning. So if I delete it from the beginning, the second node will become the first node. So that will become head. That is what I have to do. I will create a temporary node that will point to head. Then I will reinitialize head with the address of head.next and delete temp. That's it. That's for delete from start. Now let's say see what is delete from end. So for delete from end, what I will be doing is I will reach the second last node. I will reach the second last node, and what I am going to do is I will delete. Suppose this node um, what to say I refer it with the variable temp. So what I will be doing is delete temp next, and after I delete temp of next, this goes away. So what I will do is I will be reinitializing the variable temp of next with null. Let us do the implementation, we'll understand better. Now let us take a look at the deletion part. Okay, so here we have to check another thing. Suppose the list itself is empty from the start. We haven't even inserted a single element. In that case, it will give an error. So this is what we are going to do. That's it. Same for this part will remain same. Now I will have to go to the second last loop. That's it. So I checked if it's empty or not. I went to the second last node using this. Then I deleted the next node to it and reinitialized temp.next to null. Thank you for seeing. So these are all the basic operations that we can do using a linked list. Now that we are done with executing a program, let's check for any compilation errors. None are present. So before executing my program, I need to see at every step whether the linked list is getting updated as per our needs. For that, we need to display the linked list. Now, This will be the pattern in which I display it. I will be writing the value, then the next value to which it's pointing, and in case it's the last element, it will point to null. Okay, so let me go on with this. Now, first thing I have to check if it's an empty list or not. So how do I do that? If head equals null, the out empty list. Backslash n is for next line. You can also use end l return. In other cases, let me take a temporary value node temp, which will store head, and I will keep on moving. I will keep on iterating across the list until and unless I find a null. So now, since I will be printing the value, what do I do? Print temp point value because value is the variable that is storing the value of that node. Fine. Why am I printing this? For visual purposes. And in the next line, temp will be reinitialized to temp next. Now, after all of it is done, this will keep on iterating until the last loop, until the last node. So when it reaches the last node, I need to print this extra null. Oh, there I go, null. That's it. Now let us create a linked list. Let me insert at insert 12 at the start and display. Let me copy this line because I will be using it multiple times. So what should I get? Ideally, this should be my output. I created a node 12 at the beginning. That's right. Let me check if it's working. Yes, it's giving me my desired result. Also note that if I if at this point I write insert at end, we should get the same output. But no, we got exit code 139, which means there is some error. Let me try to find that error. Insert at end. So what this is doing is creating a new node. That's clear. Then iterating from head until the last node. But what if the list is empty and head is null? In that case, none of this gets executed. So we are getting an error. What do we do? Here, let's add an conditional statement. If head equals null, that means the linked list as of now is empty. Suppose this. Let us consider there is a linked list, but we cannot see it because it's empty. So head points to null, right? So if head points to null, we will just reinitialize head with new node. That's it. This does everything. Now let us run. There you go. We get our desired result. Let's move on. Let me insert. Let me change this to 56. Fine. There we go. Now let me insert list dot insert at end. Let me insert 14 after this. So what should be, so this should be the linked list after this statement, right? 56, 14, null, right? Let's check. Yes, that's what we are getting. Now let us do one thing. Let us insert 12 before 56 and 14. So what will we do? Insert at start 12. That's it. Display. So this should give 12, 56, 14, null. Let's check. There we go. We get a result. Now let us go for deletions. Insertion done. Uh, Insertion done. Now let's check for delete deletion. Same thing we are. Uh, let's do this. Let me delete the last element. List dot delete from end. What should this give? I am removing the last node. So this should be like this. 12, 56, null. Let's check. Yes, there you go. 14 is deleted. Now let me check for delete from start. List dot delete from start, then display. This will remove 12, so this will just remain as 56 pointing to null. That's it. Now let me delete this itself. Delete from start. This should print empty list. Empty list. Yes, there we go. We got empty list. Now ideally, if I also write display from end, this too should return the same output. Again, there you see, I am getting exit 139. Why is it so? Let me go to the whiteboard once. So suppose this was this is the linked list as of now. I deleted, what did I do? What was the order? So I deleted, this was the linked list. I deleted 14. So I deleted 14, deleted 14. Then I deleted 12. So now this points to null, right? This points to null. These two are eliminated. Now, what was the funda in deletion? We used to go to the second last node and then delete the last node. But here there is no such case of second last node because the effective length of linked list is currently 1. So what do we have to do? In cases where the linked list shrinks to a list with only one node, there we have to add an extra condition, right? Let's go. Let's see what we will do. So what we are going to do, how do we know that a linked list itself contains only one element? That we can easily do if we see that head next is null, that means the linked list itself is of length 1. Let's go ahead, let's implement this. So I'll find if head next equals null, head will become null, and that's it. This will do the work. This possibly should do the work. Let me check. Yes, that's all. So this is all that you need to learn about linked list and its implementation. Thank you.